Well, thank you everyone for coming. My name is Rhys. I work at mend.io, and this presentation today is not a product pitch. If you actually came here wanting to know about mend.io, look down on your lanyard. That's our website. Today I'm going to talk about a fairly dry topic, but I'll try to keep it interesting, on open source risk management. And essentially this relates to dependencies. All right. So just telling you up front the kind of topics to expect. So first up, I want to kind of get us on the same page, talk about the status quo. And that is really the kind of reactive or responsive approaches to vulnerabilities that we have today. I then want to talk about the risk of outdated dependencies on resolution time. In other words, the further behind you are, the harder it is to fix things quickly. Then, because this is about risk, the risks of updating proactively. Everything is a trade-off. All right, and then finishing up talking about dependency automation and countering update risk. And then some recommendations on risk appetite and strategy. All right, so yeah, setting the scene, the status quo. If we kind of look in terms of levels of maturity here, the first one is thankfully not that common and definitely not in the area of finance, right? And I call that one the see no evil, hear no evil approach. So there are companies that essentially have no process for dealing with vulnerabilities, no formal process, and they generally hope that it's someone else's problem or that it doesn't affect them. Like I said, this is not very common in finance, fortunately, but pretty much everybody else across industries falls into the second category. I call this the traditional software composition analysis, or SCA. And disclosure, that is where Mend kind of generally sits in the industry. Okay, so in the traditional SCA approach, you want to be alerted, hopefully immediately, right, by your vendor or by your process. You want to be alerted immediately when you have a known vulnerability. You'll likely scramble to fix it if it's important. Like log4j, log4shell. We talk about that one a lot. If we're talking the reality here, most companies ignore a lot of their vulnerabilities. So that's just the reality. We sometimes pretend, both on the, let's say on the finance company side or on the SCA vendor side, we like to pretend that you take an SCA solution and then you're vulnerability free, you manage your vulnerabilities. The reality is that most companies end up ignoring or living almost in denial about the level of vulnerabilities. So, we're not doing an amazing job. And the fourth step is, you try to ignore the fact that you're ignoring. That's the denial part. Okay. So that's kind of the status quo. And I don't mean to be too negative on it, but so next level of maturity. Maturity is going up, the list is going down, but that's doing something about it proactively. So really today I want to talk about that proactive part, but not one-sided. Really talk about the risks of being proactive as well. Because like I said, it's all a trade-off. All right, so an example of status quo, to use our favorite log4j, there's a critical vulnerability in log4j announced. You assess which projects are using log4j. Okay. Now again, depending upon whether you have a process, whether you have a vendor, whether you scan ahead, whether you shift left, your ability to know which projects are using log4j varies based on that. Now unfortunately, in the case of log4j, this was a highly exploitable vulnerability. That meant that basically if you found it, you're vulnerable. There wasn't much chances here that you weren't. Some of you might know the exceptions. Now for some projects, they needed to apply a simple patch to update log4j, push to production, and they're done. Let's not forget the push to production part, obviously. Now, there were other projects, hadn't touched their dependencies in over a year, and they took much longer to make those upgrades. That's because potentially they had to upgrade other things, not just Log4j. They had other dependencies or things related to, say, Java or something like that. So there was a lot of variance in how quickly people were able to remediate. Even same company, same SCA solution, for example. All right. So if we look at developer perception, again, looking at status quo, it isn't really great. To most developers, these vulnerability alerts, they are unplanned events. Frankly, they're unwelcome events. They are an unwelcome interruption to their real job, which is building apps, build banking apps, trading apps, things like that. It's an annoyance. It's unwelcome. Fixing those problems is a demand on their time, a burden, as I said. And then, ultimately, fixing vulnerabilities gets in the way of the real work. This is the realistic developer perception of this topic, right? So those of us who want them to fix are the boss in Office space, right? So open source security in a nutshell, mostly gone are the days of complex fixes, or what was known in the industry as monkey patching, where you take the dependency code and you literally are told to edit some lines or add lines, delete lines. Those days are mostly over. That doesn't really happen anymore. Put simply, the majority of open source security problems today can be fixed by upgrading dependencies. So it's a big industry. We have fancy terms, but in the end, what are we talking about? We're talking about not just detecting dependencies, not just detecting vulnerabilities, but fixing them. How do you fix them? You upgrade. And in fact, more than 90% of CVEs have a stable, fixed version available same day or earlier. What I mean by that is by the time you hear about it, there is a version you can upgrade to. It's not very common that you're told, hey, there's a huge problem, no solution. No, the solution is upgrade to version x.y.z. Okay. So a colleague of mine invented this kind of saying, or at least he claims he invented it. Updating dependencies like going to the dentist. If you only do it every few years, it's going to hurt. Yeah? So that's kind of the crux of what we're talking about. Fun fact, this graphic was generated by ChatGPT's DAL-E, the new one. So I put in a text that said, a dentist that looks way too eager to see you. And that's what you get. So, all right. All right, so let's, learning from Log4j. So given the same starting line, companies, or teams, in fact, let's go down to the team level, who were further behind in their dependencies took longer to mark themselves safe from the problem. Even within the same company, teams which had kept reasonably up to date remediated the problem faster than those that hadn't. So, we help a lot of companies. They were all interested in Log4j, and we saw a great variance in their ability to basically be safe and be able to sleep at night. Okay. If we look here, at the kind of the meme template I've borrowed here, developers who were behind in their dependencies essentially had two different risks, like a difficult choice, right? The first was, let's upgrade really quickly without doing the testing we would normally like to do. That's risk number one, upgrade without testing. Risk number two is to remain vulnerable while you're testing. These are two forms of risk. How much of a problem you had was really dependent upon what you'd done prior to that. All right. So, again, setting the page, what we learned so far. Resolution of CVEs, of vulnerabilities, almost always require an upgrade of dependencies. The bigger the upgrade, the bigger the risk due to the delay. And therefore, open source vulnerability risk is increased by outdated dependencies. I know it sounds really kind of basic and simple to put it that way, but these points are pretty hard to debate. The further out of date you are, the higher your risk is when you get vulnerabilities. Now, what's interesting, and the reason why I say it, is because almost no companies have a process where they want to stay up to date with dependencies as a security reason. So that first has to do with business risk. Now let's talk about breaking. Yeah. Oh, on here is okay. Thanks. Is this one working now? Thanks. Okay. So one of the most common answers you'll get from developers to why they don't want to update dependencies or why they might not is because they're worried about it breaking something. You update a dependency and the next day you get a ticket that says our sign-up form doesn't work or something like that. I mean, that's a nightmare to a developer. So if you think of the if it ain't broke, don't fix it, right? So let's cover that. And I gave away the punchline. So again, if you look at developers and risk and assessing, they've got the choice. Oh, it ain't broke, I'll just leave it like it is, or upgrade it. And you can understand why there can be a tendency to not change it if there's nothing major wrong. So automated dependency management should ideally combined with automated testing. It is a risk if you were to update a project that you have low quality control of. However, even with great tests, most people can't be certain that changes or updates are without risk. So you can have a project with great tests, and if you say to them, "Would you bet your life? We've upgraded a dependency. It is your tests all pass. How much money you want to put on it?" They still would not put a lot because it's very hard to make tests perfect. And in particular, getting a little technical, most tests in a project are designed to test your application logic, not to test your dependency logic. They often kind of abstract that away. And so it is hard to know for sure, even with great unit tests, that it hasn't broken something. All right. And so a way to mitigate this risk is crowd data. So the principle of this is that, okay, one project's tests might miss a problem. It is possible that upgrading that dependency is a problem, and your test didn't catch it. That is a possibility. But what is the chances that every single project across the whole company, maybe across the whole internet, if everybody has tested it, everybody passed, and there was a problem that no one caught? The chances of that are very low. So the more projects adopting and testing a release, this is the crowd and crowd data, the higher the chances that regressions will be caught. So then if you can surface this crowd data in a way that allows developers to take actionable decisions, you can help mitigate that. Now, as an analogy, if I had a jug of milk and I poured out a small shot glass and gave it to one person in the audience and said, "Do you think this milk is bad?" Now, you would taste it, and let's say it's not. By the way, I'm not that mean. You would taste it, but if I was asking you to bet lots of money, bet your life on it, you would be hesitant to. You'd have that element of doubt. Okay, but if I poured out one to every single person in the audience, and every single person, for those online, it's hundreds. If you were to give it to everybody in the audience, and everybody thought it tastes good to me, your confidence would be much higher, right? It's not just your own opinion, but it's everybody else's, right? So adopt that to dependency testing. It passes your tests, passes everybody else's tests, your confidence level goes up a lot. Okay, so the conclusion of this is that the risk of accidental breaking changes, because by the way, what I'm talking about is an accident here, a regression error. That the dependency says, yeah, everything's good, I fixed a bug, I added a couple of features, and they accidentally broke something that used to work. The risk of accidental breaking changes in dependencies can be mitigated through crowd data. The chances that those are not caught through automated testing, of the world or of a very large number of people, is close to zero. All right. Let's have another topic. If your developers are really switched on, or maybe you're a security person, you might say, what about malicious packages, right? Because we have all heard about that risk of one day a package has a new release and it contains something that sets up a back door or steals credentials and things like that. Okay. So let's talk about malicious versus vulnerable, because it's not always obvious to people. I want to make it obvious what I'm talking about here. So vulnerabilities, which is what we've been talking about until now, CVEs, those are accidents. They're a mistake by a developer. They are unintentional, and they're not out to get you. No one was out to get you with log4j, for example, with that problem, okay? Malicious packages, on the other hand, and sometimes it can be the whole package. There's cases where people go and publish a new package to like NPM or something, but really what we're worried about is an update, right? We're talking about updating. So a malicious update, that is intentional. It's like a computer virus. They are out to get you. That's the whole purpose of it having, malware or malicious code. So vulnerabilities might be exploited or might not be exploited. They may not even be exploitable. Like there can be like some people had log4j in a way that couldn't be exploited, even though it was quite a high percent could be. So you can have a vulnerability without falling victim. Malicious packages, though, they're usually going to exploit you 100% of the time. If you install it, you're exploited. Now, there may be some like nation-state level ones where they intentionally don't do anything for months or something like that. That's a possibility. But the reality is malicious packages are out to get you, and if you fall for it, you're exploited. Okay, so there's a big difference between these two. But the reality is, we say if a tree falls in a forest and no one hears it, did it really make a noise? Now, there are a lot of malicious packages published, and we see articles about them. Companies like ours and others are often trying to get media attention. Oh, someone has uploaded another 50 malicious packages to NPM or something. But if nobody installs a malicious package, thanks, except for like technical companies like us, whose job is to protect you from them, if no one really installs it for real, is it really a threat? Okay. But importantly here, let's narrow it. We're discussing the risk of updating dependencies we already have, not the risk of installing a brand new package by accident, like a typo or something like that, because this is the risk of updating, right? So, malicious package risk, good to bad. Okay. So the majority of risk from open source, or from malicious open source, sorry, is when a safe package turns bad. It was fine, it was normal, somehow it went from good to bad. Now, this can be due to what's known as an account takeover. So an open source developer has their credentials stolen, or maybe they reuse their password, something like that. Or potentially, and this is a real narrow case, the original author maybe had bad intentions. Maybe they turned from good to bad. Maybe they were always bad, and they just published a package to get people to install it for years, and then they wanted to do something like steal your credentials. Now, these events are increasingly rare, okay, thankfully. In fact, the last major such case was in 2018 with the event stream package in npm.js. That was a big one. That was a popular package where the maintainer of it gave it to someone else to maintain. He said, I don't even use this anymore. If you want to maintain it, go ahead. The person tricked him by fixing some bugs at first, like long-running bugs, fix some bugs. And he said, oh, yeah, I'm using this. Hey, I really want to help you maintain it. And the guy said, help me, take it. I don't want this package anymore. And then the person who took it, it was their intention all along. They added in a back door. They published a new version when they were in control of it, and people were exploited. Okay. But we haven't had a case like that since 2018. Okay. So if we think of risk management for malicious packages, the risk to enterprises is good packages turn bad. Like the stuff you often read about, like, oh, some malicious actor has published, hundreds of packages. That's not a risk for you when you're thinking about normal updating, dependencies. These instances are rare. Such instances are usually noticed quickly, same day or week. Like when we scan for malicious, we scan in real time as an example, and we're not the only company doing that. We then report them to the registry like NPM or RubyGems, and they're taken down pretty quickly. This is a nice way of like capitalism at work. There's multiple security companies that assist registries by scanning and reporting malicious packages. Okay, so the risk of malicious packages is low if you're not updating immediately. Like if you're not taking those releases same day within hours, the risk tapers off dramatically. Okay. So now, just weighing up the risk, right? So the do nothing approach, do nothing by default approach, I should say. React only when necessary. Traditional SCA, no real process except have a good SCA vendor, and when they tell us there's something important, we scramble. let's see, the reward for that approach, and it is a very valid approach. The reward is less work most of the time, because you're not, thank you, 5 minutes, most of the time you're not doing anything. You wait around for the next log for J, okay? The risk is that there is a longer time to remediate and a higher risk to remediate, because it's going to take you longer to do, and your risk is higher. The risk that you break something in production while trying to fix the problem quickly is much higher if you're doing a very large update of dependencies versus if you've been keeping reasonably up to date. Now let's compare that to what I'm nicely calling the proactively update approach, keeping dependencies relatively up to date. So the reward of this is your ability to remediate vulnerabilities quickly. If you got an alert tomorrow for a new critical vulnerability, and it was just, you're on version 2.3.0, and you're told to update to 2.3.1 or to 2.4.0, you'd look at it and you'd be like, oh, okay, well, that's not much. You look at the release notes, they'll say, 3-line fix to fix a DDoS, attack vector. And you'd be like, yeah, well, that's safe, and you'd update and you're done. If instead, you were on 2.0.0 or maybe on a 1.0 and you had a big upgrade to make, you won't be able to do it quickly. You won't feel confident in it. And you're not going to be able to remediate it quickly unless you do so with a high risk. So then if we look at the risks of proactively updating, it is potential malicious packages, and it is the fact that, hey, it wasn't broke, but you fixed it. Because the reality is, if a system was running fine and you updated dependencies and you did break something, people are going to say to you, oh, why did you update? It was fine, wasn't it? Right. So this is the kind of risk reward of either taking a reactive approach versus a proactive approach. Right. Business versus security risk. Being up to date with dependencies is inarguably the safest from a CVE point of view. Like, if you are up to date, then it's going to be the smallest change to make when problems come. You do have lower risk. It's not only easier to deal with CVEs, you may get less CVEs, because sometimes a vulnerability is fixed weeks or even months before it is disclosed. And if you were on a weekly or monthly even updating system, you would avoid some CVEs. You would already have fixed them before they were announced. Not every app is mission critical though. So for example, if you have apps that you could take down, if you could take it down for hours or even maybe days to give you the chance to test, that does also change your risk evaluation there. Because you say, well, in the worst case, we're able to take this down. It's okay. People will come back. All right. So finally, dependency updating, burden or opportunity. Now, developers might find vulnerability fire drills to be a burden, but they rarely want to be using outdated. It's not like developers say, I want to be on outdated dependencies. On the contrary, developers want to be using the latest version of dependencies like we want the latest gadgets. It makes sense to be using the latest and greatest. It's their toolbox. So developers do want to be using the latest tools when possible, and they never start on old tools. When a developer starts a new project, they always have the latest. Okay. So dependency automation really is becoming a pillar of software development like test automation. You should have a system to detect, to update, and weigh up your risk. Thank you very much. I finished in the time. Do I have a minute in case there's a question? Yeah, okay. Any questions, comments? I should have planted some questions in the audience. No? Okay, well, thank you very much for coming along today. If you are interested to learn more, conveniently, our name is on your lanyard. And the tool that I mentioned before, this is the free open source tool. It's called Renovate Bot. And so if you want to go directly there, it's men.io/renovate, and that will take you to our information page. Thanks again.